Hello everyone. So we are having log x to base 2 plus log s to base 3 equals to 1. X is the unknown, but we can see that the bases are different. So we are going to solve together by saying solution. And here we are going to use also two methods. The first method we use log s to base 2 as the subject of the formula, and the second method log s to base 3 will now be the subject of formula. So we say log x to base 2 will be equal to 1 minus log s to base 3. But log a to base a is equal to 1. That means log 3 to base 3 can be regarded as 1 also. So in the place of 1, we'll put log 3 to base 3. So the equation becomes log x to base 2 equal to log 3 to base 3 to be 1 minus log s to base 3, and we are fine. And also log a minus log b is given to be log a over b. So we apply it here. The equation therefore becomes log x to base 2 equal to log 3 over x to base 3. So here we will say let it be equal to y. That is, let log x to base 2 equals to y, and we call this equation 1, and log 3 over s to base 3 equals to y, and let this be equation 2. Log x to base a equals to y can be transformed to s equals to a raised to power y. This is in the log form and this index form. So we are going to transform our equation 1 and 2 from log form to an index form. That is to say, from equation 1, s will be equal to 2 power y. Let's call this equation A. And 3 over s will be equal to 3 power y. And let's call this equation B. So in the next line, we're going to say multiply equation A and equation B, which will become 2 to power y times 3 to power y is equal to x times 3 over x. And here, 2 to power y times 3 to power y is 6 power y equals to, here s will cancel s is over 1, we'll be left with 3. So this is 6 power y equals to 3. So in the next line, we're going to take the log of both sides to base 6. That is, log 6 power y to base 6 equals to log 3 to base 6. And you know log 6 to base 6 is 1. So what will be left on the left hand side will be y equals to log 3 to base 6. So in comparison, we have y to be equals to log x to base 2 also equals to log 3 to base 6. If we want to transform this to an index form, s will be equal to 2 log 3 to base 6. And this is the value for s for the first method. In the second method, log s to base 2 plus log s to base 3 is equals to 1. Here, we're making log s to base 3 the subject of formula, and it becomes log s to base 3 equals to 1 minus log x to base 2. And as usual, log x to base 3 will therefore become log 2 to base 2, which is 1, minus log x to base 2. And also, log x to base 3 will be log 2 over x to base 2. And we call this p. So here we're going to say let equation p be equals to y. That way, we will generate two equations as log x to base 3 equals to y, equation 3, and log 2 over s to base 2 equals to y, equation 4. So if we write equation 3 and equation 4 in an index form, it will therefore become s equals to 3 to power y as equation C, and 2 over s equals to 2 to power y, equation D. We multiply equation C and D, and to become 2 to power y times 3 to power y equals to x times 2 over s. And here, 2 to power y times 3 to power y will be 6 to power y equal to 2. Since s, we cancel out s. And we're going to take the log to base 6 on both sides. That is, log 6 to power y to base 6 equals to log 2 to base 6. And log 6 to base 6 is 1. So what is left on this part is y equals to log 2 to base 6. So here we had y equals to log x to base 3, and here it's also equals to log 2 to base 6. So from here, s in an index form will become s equals to 3 to log 2 to base 6. So from the first method, s was equals to 2 log 3 to base 6. And the second method, s is equals to 3 log 2 to base 6. But a to power log c to base b is equals to c log a to base b, which means 2 log 3 to base 6 is equal to 3 log 2 to base 6, which is equals to s. And this is our answer. S is therefore equals to 2 power log 3 to base 6, also equals to 3 to power log 2 to base 6. Thank you. Bye-bye.